Hey everybody, Mr. Covey here, and today we're going to be talking about domain and range. Okay, so these are two very closely related ideas, and really, kids get messed up with domain and range, but it's really not too bad. Domain is just what are the possible inputs? What are the things you can input into a function? What can you put in? Remember, if we're thinking about like variables, input are x's. Okay, so you put in x's, all of the possible x values is called your domain. There's a few different ways we're going to list all these. Domain is your x's, your inputs. Range is your outputs. It's your y values. Okay, so just a list of all the possible outputs. Okay. If you have a function represented with a mapping like this one and like these two, domain and range is actually really easy. It's literally just a list. What are the x's? Oops, I guess. So literally just 1, 2, 3, and 4. Those are the possible inputs. That's it. That's all that's listed for x's. When you have a list in math, sometimes it's nice to put these little curly brackets on the outside. Same with range. What are the possible y's? What are the outputs? Well, you can get out D, you can get out B, and you can get out C. That's it. Put some little curly brackets around it. Done. Is this a function? Yes. No input, no x goes to two different y's. Next one. What's the domain? Well, what are the x's? Negative 2, 3, 4, and 10. Fancy little curly brackets. What are the range? What are the outputs? Easy. Negative 1, 0, 2, 4, 6. List those out. Toss some commas between them. Do some curly brackets. Is it a function? No. Why is it not a function? Because 4, an input of 4, shooting a bunch of different places. I don't know which output goes with 4. Okay, so that is not a function. Okay. Here are two more mappings. Why don't you pause, try and do these ones on your own. Okay. Again, list the domain, list the range. Tell me if it's a function or not. Actually do it. Pause. Do it yourself. Okay. Take a minute and check your answers there real quick. Notice that both of these are functions because no input in the domain has more than one output in the range. Okay. I know what you're thinking. You're like, this seems too easy. And that's because it does get a little bit trickier, okay? And specifically, it gets a little bit trickier when we start to look at graphs, okay? And the reason this gets a little bit trickier is because what are the x's? For instance, if you look at this graph, remember we've got x's going across, y's going up and down. What are the x's? Well, don't do this. This is what kids do. They think like negative 3, okay, negative 2, negative 1, 0, 1, 2. No, 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 no. Those work. Those are x's that work. Like, you're totally right. Like, those are the x's. But what you're forgetting about is all the in-between, right? Because you can put in, like, there's a point right here at 2.5. X value of 2.5. And there's a point there, there's a point there, there's infinitely many points. So if you were going to try to list out all of the x values, you'd be there all day. You'd be like, you can use 0.1, 0.12, 0.13, 0.14. It'd take you forever, okay? Instead, we use that interval notation. Okay? And what you need to think about here is you're doing domain, you're talking about x's, and you need to think left to right. What is the furthest left x value? All the way over here, negative 3. It's the furthest right x value. I want to say all of the numbers from negative 3 to 3. I say negative 3 comma 3. And then the last thing is I use brackets here. And the reason I use brackets is because I want to include those numbers because you'll notice there's no weird open circles here. Left to right, left. Domain is x's left to right. This is the way you should think about it, okay? So here, What's the furthest left x value? -3. Furthest right x value? 1. Now here I have an open circle at -3, so instead of using a bracket, I need to use a parenthesis. But at 1, at an x value of 1, I got a closed circle, so I'm going to use a bracket at 1. With her? How far left to right, left to right? Ooh. There's something wrong with doing like this. That's because, true, it looks like the farthest left it goes is -4, but what do we have at negative? Ooh, we got an arrow. Meaning it goes on and on and on and on and on. How far left does it go? It goes as far left as you want. It goes to infinity, all the way left. Except for, remember that like as you go left, you get negative. So it goes all the way left to negative infinity. It goes really far left. How far right? It goes to 5. Bracket at 5, because we hit 5. Can you hit infinity? It's like a mind bender right there, right? You can't hit infinity. You're not going to touch infinity. So you always put a parenthesis with infinity. If you want to write that down with interval notation, it's kind of a good thing to write down here. We'll write down here at the bottom. You're using, oops, sorry guys. You're using interval notation. Always use a parenthesis. I'll check here. With infinity or negative infinity. Always use a parenthesis with infinity. Negative because you never touch them. Cool. So there's our domain, negative infinity to 5. This one? Oh, double arrow. So it goes all the way left and all the way right. How far left? All the way left. How far right? All the way right. Can you touch negative infinity? Nope. Can you touch infinity? Nope. Why don't you give this last one a try? Go ahead and pause. State the domain. Again, domain means x's. How far left? How far right? Go ahead and give it a try. Okay. You should have gotten bracket -4, comma 4 with a parenthesis. So it goes x value -4 to an x value of 4. We got a closed circle at -4 and an open circle at 4. So then we have a bracket and a parenthesis. All right, let's do a little practice with the range. Again, range works very similarly, except instead of talking about left and right, talk about bottom to top. And range is a little trickier for people. Make sure you do bottom to top because you got to go small to big. So bottom to top, not top to bottom. Okay. Cool. So let's do a couple of these. I think you guys are going to hang up. We're going to look at kind of the same kind of graph here. So what's the smallest y value? What's the lowest the graph goes? Well, like here and here, it's both as low as it goes. What is the y value there? Well, it's a y value of 0. What's the highest it goes? Well, 2. Does it actually hit 0? Yeah, because that's a closed circle. Does it actually hit 2? Yeah. So we use bracket. Okay. And bottom to top. Never write it top to bottom. Okay. What's the lowest this graph goes? What's the bottom? Well, -4 actually hits it twice. Doesn't matter how many times you hit it. All that matters is how low you go. -4 is the lowest. What's the top of this graph? Well, right here and right here. Both of them are 0. It actually hits -4. Does it hit 0? Well, it doesn't hit 0 here. That's why it's open. But it does hit 0 here. If you don't see any dot at all, it means it's a closed dot. Otherwise, they'd have to show you the open dot. So no like specific dot means it's closed. So we actually do hit it there. So both of those need brackets. It's a little tricky. Bottom to top. How low does this go? It goes all the way down. All the way down to -infinity. How high up? Right there. Again, we're talking range, so we're talking y values. What's the y value there? It's 2. Do I hit the 2? Yep. Can you touch infinity? Why don't you go ahead and give 4 and 5 a try? Again, it's bottom to top. Okay, y values. Pause and give it a try. Okay, let's check those two together. So for number 4 here, the lowest it goes is right here. And that's a y value of -1. The highest it goes, well, it goes all the way up to infinity. Parenthesis on infinity. Okay, bottom to top, what's the lowest point? That's the lowest point. What's the y value there? -4. Bottom to top, there's to the top. And, oops. Top there is at 4. We got closed circles on both of them, so we use brackets. Take a little practice for you guys to make sure you have that down, but we'll definitely do that, so don't worry. Cool. Thanks for watching.